Okay, as always, our recordings of our virtual meetups will be available on YouTube about a week after the meetup, and we will post a message on Meetup when the recording is ready. Next, I am very pleased to introduce our speaker today, Eduardo Blancas. Eduardo Blancas is the co-founder and CEO of Plumber, a Y Combinator-backed company developing tools to bridge the gap between interactive data work and production. Before that, he was a data scientist at Fidelity Investments, where he deployed the first customer-facing machine learning model for asset management. Eduardo holds an MS in data science from Columbia University. So today, our speaker is fine with you asking questions throughout the talk. So he also makes some stops along the way of the talk. If you want to jump in, just feel free to put something in the chat, and I'll ask the questions during one of the stops. Okay, Eduardo, take it away. If you aren't able to screen share, just let me know because I was changing some of the settings.
Okay, let me try to share. I think it's working.
Yep.
Can you see my slides? Okay, cool. Let me test my controls. Okay, cool, working. Hi, everyone. Thanks a lot for joining today. I'm excited to be presenting the talk. And yeah, so we are gonna walk through this. There's gonna be a lot of information here, but I have a lot of links, and I'll also share the URL where you can get the slides. The important thing is to get a high-level idea, and then you can go to the links that I'm gonna share and like take a deep dive into the resources. All right, so let's start. So today we are going to be talking about running notebooks in production, right? Maybe you heard this before. There are a few companies that do this, that run notebooks in production. And I think when I share this with other data scientists or other practitioners, many get the idea that this is like something crazy and that you should never do it, right? There are good reasons for not carelessly deploying notebooks into production, but I think it's important to get into the details, like understand why some people don't like this idea, but why there are others who actually promote this, and why, what's the way of promoting this, like what's the reasoning. So we are gonna go through all this important stuff and all these details, right? And you may, if you've been doing data science or data analytics for a while, and you have used Jupyter notebooks, you know that if you start working on a notebook, things become a mess really fast, right? You start adding a few cells, you start adding some code, and then all of a sudden, maybe a few days of working with your notebook, it's like 200 cells, and then things break, and then you cannot reproduce your results. But we can actually use Jupyter notebooks in a maintainable way, and we can develop high quality production-ready code. And this is what this talk will try to convince you about. So hopefully it will give you the tools to try it by yourself and see that it works. Now, before I continue, there's actually a really interesting use case from Evidation Health, a healthcare technology company. They use notebooks in production, and you can see it by yourself. There's a link here. You can look at their use case to see a real industry use case of notebooks in production. And we're going to cover many of the things that they do in this talk. All right. Now, before I start, there is something really, really important to know, because I feel like whenever the people who advocate to run notebooks in production like me, this is like the most important thing to mention, because many of the discussion turns around this idea and this fact. Jupyter is actually two things. It's a file format and it's a platform. And it's important to study this from this angle where we take into account both parts of the equation. When you're working on a Jupyter notebook, you are storing this type of file. The IPyNB format is actually a JSON file. So when you're working on a typical Jupyter notebook, if you open your notebook with a text editor, it's going to look like this, right? This is a JSON file with a specific schema, and this has some benefits and some disadvantages. One of the main benefits is that you can record the output of your code in a single file. Then you can share this file with someone else, and then they'll be able to see your charts, everything that you produce in your notebook without having to rerun anything. because your notebook contains all of these things in the same file. Now, it's also a platform because if you take a notebook and open that file in Jupyter Lab or the classic Jupyter notebooks, you'll have all these buttons and features that allow you to edit this notebook. The important thing, and this is like a really essential piece that I want to share, is that you can use this independently. And let me explain that a little bit. One of the most important tricks to write clean notebooks and use Jupyter notebooks in production is to just use a different format. And this is something that most people don't know, but this really changes a lot of the ideas. There's this package called JupyText that allows you to have different file formats that when you open them, they behave like a notebook. One of the most popular formats is this .py file with specific annotations. So this is your typical .py file, except it has a few extra marks. You can see this, and you can see this. This special marker separates the notebook, because this is actually a notebook in .py format, and this you can use this marker to separate different cells, right? And you can use other formats. JupyText supports Markdown and many other formats. So this is really important thing for you to know. You can use alternative formats, and then you can open them as Jupyter notebooks. Now, what's the main benefit of this? If you're using Git, then storing .py files makes things a lot easier for you, because since I mentioned before, the IPyNV format contains output and many other things that make it a bit tricky to work with Git. It also helps with interoperability, because maybe you like notebooks, but maybe your colleague likes VS Code or Spider or PyCharm. All these IDEs can open the same format. So then if you like notebooks, you can open Jupyter, change this file, and then your colleague can use VS Code and edit the same file. All right, so now let's dive into the details. So this talk is, I split this talk into 3 sections. The first part is how do you write clean notebooks? How do we keep the standards high so we are able to reproduce our code, make our code readable, and make sure that when we come back to our notebook, we understand it. Now, there's also, you'll see that I'm sharing a lot of links, and there are a few recommended reads. There's a longer version of this section in our blog, so you can go to plumber.io/blog/clean-nbs, and then you'll see like a longer version of this. All right, so one of the first properties of clean notebooks is that they are short. If you have a notebook that has 300-400 cells, it's going to be really, really challenging to maintain. So the first thing is keep your notebook short and follow the same structure. Have a standard structure so you understand what's going on and other people understand what's going on. Now, what's that structure? I don't want to be too prescriptive. I'm sharing what's been working for me through the years, but always, if you have questions, if you feel like there's something you can improve, you can suggest things, right? That's the spirit with all these practices. I'm going to propose a few things, but maybe a few things don't work for you. So maybe you can tweak it a little bit. Okay, this is the structure that I follow with all my notebooks. At the beginning, I have all my import statements, essentially all the libraries that I'm going to use. Even if I'm using one specific library at the end of my notebook, I put the import statement at the beginning. The reason is that if I open the notebook, then I'll know what libraries I'm using. If I put my import statements in the middle of the notebook, then maybe I'll start executing it, and then I'll realize that I don't have that library. So having these import statements at the top kind of sets up expectations of what libraries you are going to use. The second important thing is the configuration. Often you have to prepare a few things before running your code. For example, if you are connecting to some database, you have to create the database connection. This is just an example of other things. Maybe you are logging your results. It's important to put all the configuration in the same place. And the reason is the same. If you open a notebook and you see one cell with all the configuration, then you know what's going on, right? You know that this notebook is communicating with some database. It's logging the experiments to an external server or any other external thing that you need. You can put that here. The next part is the data loading. If we are going to use Jupyter notebooks for analyzing clean data, we have to load the data at some point. And I recommend you put this right here. where someone who's reading the notebook can see all the data that you are going to use. And then you repeat the same recipe. Once you load the data, you repeat the same recipe for all the sections. You have a markdown heading. A markdown heading is just some text, and then you have some title where you can quickly explain what's going on, like just 1 or 2 words. Then you can add some text below to explain what this section is gonna do. Then the takeaways, kind of the conclusion of what this section is, and finally the code. So if you follow this recipe, you'll see that the code becomes a lot clearer and easy to read. Okay, so now let's move on. The second advice that I have is in terms of the code. Let me show you an example because that's gonna make things a lot easier. Let's imagine that you are using Pandas, really popular library. I'm sure you have used it many, many times. And you have a function, right? You know that modularizing your code is important, so you have a function that performs some transformation. In this case, that transformation is taking the zeros column and adding 1, right? That's all it's doing. It simply adds 1. And then you initialize your data, you load your data. So I'm passing 3 zeros and naming these columns zeros, and then assigning it to this data frame. Now imagine you have a bunch of code, maybe 100 lines of code. And then you have something like this. Maybe you remember that your data frame, df, has zeros, right? What happens if we run this function? Look at the implementation, and we are overwriting the values inside the data frame. And if we print the value, we'll see that it actually contains 1s. Now, this example is really simple, but when you have maybe 200 lines of code, it becomes really hard to understand what's going on. And it might be surprising to you to see that your data frame contains 1s instead of zeros. The problem is that we are modifying our argument. So the argument of this function is df. And from here, we don't know if we are modifying df or we are doing something else. It's unclear what's going on. We have to look at the implementation, and this can cause a lot of headaches. Now, how do we fix it? Well, we create immutable code that doesn't change the arguments. Look at the difference between the first implementation and the second implementation. In the second one, we are copying the data and we are modifying the copy of the data. So if we initialize our data and we apply the transformation, ones contains the number 1 because we are adding 1, but df contains zeros, right? So if we still remember that we loaded all zeros, all throughout our notebook, df will still contain zeros, no surprises. Now, of course, this simple approach is not feasible when you are dealing with large data sets because copying data, it's going to add a lot of overhead in terms of the memory that you need. But for many cases, it works. It's a simple approach that works. If you are dealing with big data sets, then there are other techniques that you can follow in order to prevent this kind of surprises. Great. Now, moving on. One important thing about your code is that most likely you're using external libraries, right? You might be using Pandas, NumPy, scikit-learn, and these libraries changed. The scikit-learn that you used a month ago is different from the one that you get if you download the latest version. Many times it will be fine and your code will just work, but sometimes maintainers have to make breaking changes. Maybe people are suggesting that some argument is confusing. Maybe they are deprecating some APIs. The bottom line is that things may break. Like your notebook may work fine just now, but a few months from now, it will break with the same code, with the same data, but different versions. How do you protect against those changes? Well, you have to record all the versions that you are using. So if you are using package A 1.1 and package B 2.4, you want to record all those things. So next time you try to run your code, you recover these same versions and you run the code with them. And how do you do that? Well, once you install all your dependencies, you can run this command. And this is going to auto-generate all these lines. all these packages with all these versions. And now, let's say 3 months from now, you share your notebook with a colleague, and then you send both the notebook and this file. If they take this file and then use pip install, they'll be able to recreate your environment, and they will get the same versions that you had 2-3 months ago, and you'll make sure that they are able to run it. Now, this is like a really, really simple trick that works really well. It's just one command, you create a file, and that's it. And if you change your dependencies, you can run it again to get the new changes. All right, so we're almost done with the first section. The latest part is about the format. When we are writing a bunch of code, especially in Jupyter, we may just be typing things, running some experiments, and at some point we are like, okay, this is working, this is the final version, I'm gonna move onto a different thing. Your code, your experimental code may look like this, right? A few lines here and over here, maybe some white space over here, and it's a bit hard to read. Like, it's good that you're making those rapid experiments, but if you come back to your notebook or someone else reads your notebook, they will have a hard time trying to understand this, right? And making good use of white space in the notebook helps a lot with readability. Now, what you can do is auto-format your notebook, meaning you pass a program that takes the same code and transform it to make it more readable. It's still the same code. It's going to do the exact same thing. It's just that looks different. Look at the example on your right. It's the same code, except this one is passing one column to data frame in one line of code. This should actually be C, so X, Y, C. And you can read that one line per column makes a lot of sense, because if you look on the left, it's kind of hard to see that you are going to create 3 columns. On your right, it's easy to see that you have X, Y, and this other column. And this is just one example of what these formatters do for you. The other thing is that if you're writing, and this is just another specific example, if you're writing some if statements, you may break the logic into multiple lines by using the backslash. So the backslash, you can put it here, and then you can break down this if statement into multiple lines. It's a bit harder to read, and you can use parentheses for that. So if you auto-format this thing, you'll see that it automatically fits this into a single line. And if it's a long if statement, it will automatically break it down with parentheses, which is a lot more readable. Now, we don't have time to do these things manually, right? We just want to get things working and then move on. You can use this package that we are developing, and it will automatically do the formatting for you. This standard for formatting is called BLACK. It's an official package, a package that many people in the Python community uses. We just wrote a wrapper that makes it possible to use this formatter in Jupyter Notebooks. All right. Now, the last section, the last part of this section is splitting logic from narrative. The idea with notebooks is that you are telling a story about your data. You are transforming your data, you are cleaning your data, and you're essentially doing a recipe, right? Step 1, step 2, step 3. Now, some steps in that recipe might be more complex than others. So we can split the code into 2 different types. The first one is the logic. Functions that encapsulate some steps, some logic, and classes that encapsulate some logic. And the narrative. The narrative are all the plots, all the chains of transformations, and the story that we are telling about our data. Now, if we split this into 2, things become a lot more readable, because if someone opens your notebook and they see the story, they can quickly understand what's going on at a high level. For example, you can see that I'm loading some data here, and then I'm adding 1. I don't know exactly what's the implementation of this function, but based on the name, I kind of guess what's going on. And then I can split my logic, my functions, in a separate file. So I have a transformations.py, and then I import these transformations.py into my notebook. So this split helps a lot for you, because you can test the logic separately, and also for your readers, because they are able to open the notebook and see kind of the story. So it's a little bit of extra work because you have to create a new file, you have to move your code into that separate file, but you'll see that you'll be able to create cleaner notebooks and your code will be a lot more readable. All right, so that's the end of the first section. Now let's talk about testing notebooks. This testing notebooks is a lot more challenging than you would expect because most of the time we are analyzing data. And if we analyze data and the data changes, the code may break, right? So we have to take into account both the data and the code. Now, if you're interested in taking a deep dive into these two topics, we have two blog posts, and I have the links right here. But let's start with, I'm gonna mention 3 types of tests, and those have different objectives. The first one is testing outputs. When you run your notebooks, some of the cells may generate outputs. For example, here I am training a model, and then I'm printing the accuracy of that model. So you see that this is 0.963. Now imagine that I make a few changes to my data set or my transformations, and then this turns out to be 0.8. If I'm running things manually, I'm gonna be surprised. I'm gonna be surprised that this changed too much, and then I think this change is worth investigating. When I'm analyzing data and see these radical changes, I usually go back and analyze my code, see what I changed, and try to come up to a conclusion, right? Maybe it's right, maybe I added some data and my accuracy dropped, or maybe not, maybe I introduced some change. But this manual process takes a lot of time. So we have a new package. This is something that we are working on, an open source package called MB Snapshot that allows you to capture these outputs historically. Essentially, every time you run your notebook, you can record some outputs, and then we can define an expected range. In a normal, let's think about this accuracy score. If you train the same model with the same data, but slightly different parameters, or maybe you have some randomness in your code, it's expected for these results to change just a little bit. So we use that variation and take it into account to define an expected range. So if your value falls inside that range, it's all good. You can run your notebook and it will be fine. If it falls out of the range, then you'll see an error. And then you'll have the chance to investigate what's going on. So it's a way to automate the manual checks that we still do when we are running our code. So this is the first type of testing the cell outputs. Now, the second one is highly related because in some cases you are printing some values like here, but in other cases you might be creating new files, right? If you create new files, it's important to also test those files. And the most important example here is data quality tests. So let's imagine that you have a notebook and you're cleaning some data, and then you store that clean data into a file. Maybe you're making some assumptions about what clean data means. Maybe for you, the definition of clean data is that a specific column doesn't have any NAs, or maybe that it doesn't have any negative numbers. That depends on your project and the expectations that you have about the data. And as you can see, testing is all about automation. I have those expectations, but it's best to make sure that those expectations are true every time I run my notebook. That's the idea with testing the outputs of your notebook. Once you run your notebook, you can have a function like this and check the output of the notebook. For example, here, I'm checking that the column doesn't have any NAs and that the column doesn't have any negative numbers. Now, if something changes here, I want to know, because maybe the data changed, or maybe I changed my code and I made some mistake. You can embed this logic into your notebook, or you can use a library. We also have a library called Plumber, which allows you to do this, essentially having data quality tests, and they run after you run your notebook. So it's a way of automating these checkings. All right, I'm gonna stop for a few seconds in case anyone has any questions. Okay, looks like we're good. You'll still have time to ask me questions at the end. Okay, now testing notebooks. As I mentioned before, let me go back to here. Sometimes we have to encapsulate some logic. Maybe you have a few functions or classes that encapsulate some logic. We have to test those as well to make sure that they are working as we expect them to do. So there are two approaches here. If you split, as I mentioned, the narrative from the logic, then you can import your logic into a separate file and then test the implementation. This is the approach that I recommend because it allows you to test things in isolation, and then it also allows you to import your functions in any other notebooks and reuse them, right? You define them in a single place, and then you bring them to your tests, you bring them to your notebooks, and you only use one single definition. If you want to implement this, you can use PyTest. Now, there are other approaches as well. If you don't split the functions from your notebook, which is also fine, if you're working on a small project and the whole analysis fits well into a single notebook, it's fine to define those functions. I think the most important part of organizing your code is to see what works for you in your specific use case. So I actually sometimes define functions inside my notebooks if I know that I only need that function for that specific notebook, and maybe I'm running some simple analysis. So if that applies to you, and you are embedding your functions inside the notebook, you can follow this second approach. So this library is called testbook, and it's kind of similar to the other approach, except you tell the library where's the notebook that you want to test. So let's assume is this path to nv.pynb. And then this library allows you to extract certain function from the notebook. So I'm telling this library to get me the add1 function inside the notebook. Now this returns me this function, and then I can test it. Right? It's a good approach. If you already have some legacy code, some existing notebook, this is a good way to get started and add some tests to your notebooks. And this library has like other features, really nice, and you can check it out. All right, so now we are going to start talking about the third section, which is building data pipelines. Again, if you want to take a deep dive into the details, you can look at our blog, plumber.io/blog/clean-pipelines, and you'll get more of these details. Now, before, in one of the previous sections, I explained that having short notebooks helps you a lot to make sure that you can maintain that code and it doesn't have too much logic. Now, you might be wondering, how can I come up with a short notebook if my analysis needs lots of different parts? Well, the solution is to build a data pipeline. A data pipeline is essentially breaking down the whole data analysis logic into multiple pieces and then modifying those pieces in isolation and making sure that those pieces are able to communicate with each other. So let's go with the first scenario where you have all your logic in a single file. Maybe it's called analysis.ipynb. Now, one important thing is, remember that at the beginning of the presentation, I mentioned that you can use Py files as notebooks using JupiText. Now, this same logic applies. If you have an IPynb file, a Py file, or a Markdown file, the same logic applies. Okay, so let's say you have a really long notebook that has 200 cells. It becomes really hard to maintain. You can represent the same notebook in multiple small pieces. For example, instead of analysis, you may have a load notebook, a clean notebook, and a plot notebook. Instead of having 200 cells, you may be able to split them into smaller chunks. And at the end of the notebook, you store a file. The next notebook loads that file. And then the final notebook loads the second file. Now you can see that by breaking down this logic, it's easier to understand what's going on. Because if you show this to some colleague and they see this, they understand that you have 3 different parts. And if they are interested in something specific, they can just open that part and they don't have to read the other details that might not be relevant at the moment. Now, the other important thing is that by breaking down this logic into multiple files, you are bringing some kind of complexity to your project because you have to manage multiple files, right? That's why having long notebooks is sometimes convenient, because you just keep adding code and code and code, and it's convenient because you have everything there. But it comes with a lot of disadvantages. So if you break down the logic, you're adding a few new files, a few extra logic to store those files and then load them in the next notebook. But you'll see that it pays in the long run. Now, to make it easier for you to build these kinds of things, you can use our library. It's open source. And if you already have legacy notebooks that look like this, you can use another library that we are working on that automatically takes this and converts that into a pipeline. So you save a lot of time. You don't have to go through your code and then create a new file and copy paste. This will do it for you. And then you can start working with multiple small pieces. All right, so that's all I have. One quick announcement. We are running a free online course, a longer version of this presentation with a lot many things that I didn't cover. You can sign up here, and you'll learn many tricks to be able to run notebooks in production. Now, if you are interested in getting the slides, you can go to this URL and you'll be able to download them. So that's all I have. I hope this is useful and you learn a few tricks, and now you are able to create a lot more maintainable code, and you are able to deploy those notebooks into production, and it makes things easier for you. And now, if you have any questions, maybe right now they don't come up, maybe tomorrow, you can always reach out to me. I'm happy to chat, happy to help you refactor some notebooks or think how you can apply these practices to your projects. So here's my email. Feel free to reach out to me. So now, feel free to ask me any questions.
Yeah, feel free to put a question in the chat or request to unmute yourselves to ask a question. I'll bide a little time in case people are still thinking. Eduardo, thank you so much. We had you, I think, around this time last year as well. It's really cool to see how your work has progressed. I think you didn't have Y Combinator at that time. Yeah, so it's really encouraging to see the progress in this work.
Yeah, it's exciting. Last year, I was still part-time, working on Plumber part-time, like just on the weekends and the evenings, and now I'm able to work on this project full-time. So it's pretty exciting because we can implement features a lot faster. We can come up with new ideas. And yeah, it's great. It's great to share the updates with the PyData community.
Great. Yeah, I see Ravi has their hand up.
So Eduardo, thanks for the presentation. I have a quick question. How can you incorporate MLflow in notebooks? Generally, people do that in the Python files, but can you do that like an MLflow framework in notebooks?
Yes, that's a great question. We have an example. So let me reshare my screen. I don't think I have the specific link, but anyway, you can go to GitHub and then find our organization. So github.com/plumber/projects. We have tons of examples. One of those examples is integrating Plumber with MLflow, and you can download it and run it. Now, how it works? It essentially, let me see if I find some. I think this diagram is going to be useful. Yeah. So imagine you have a notebook that trains a model. Right? Let's say it's your last notebook. At the end, you can use this. Yeah, exactly. So Plumber has this feature that allows you to run a function after you execute one notebook. Now, for this specific use case, I am checking data quality, but the logic can be anything. So if you look at the code, you'll see that what we have is a function. So you have your notebook, you train a model, and then you run a function. That function takes the performance of the model file, and it uploads it to MLflow. So essentially, you can split the code, you can split your logic into two parts, the notebook that trains the model, and the function that runs after you execute the model that stores everything into MLflow.
Great. Thank you.
Yep.
Great. Any other questions? I think we do have some time. Oh, there's one. Yeah, one from the chat. Tony asked, do you schedule your notebooks?
Yep. So we don't have any scheduling feature in Plumber. What you can do is export if you use Plumber, you can export it to Airflow, and you can use the Airflow scheduler, or you can use cron. Now, if you are using just a notebook, there are a few libraries that allow you to schedule notebooks. Like one thing is you can take that notebook, wrap it into an Airflow pipeline with a single task and use Airflow. Or you can use cron as well. And you can use Papermill. Papermill allows you to execute single notebooks, and then you can call that library like every day. We actually use Papermill under the hood for Plumber, so it works the same. But essentially, since running notebooks is running one command, any scheduler that allows you to run some bash command will work. And then you can define what you do after the execution. Typically, what teams do is they execute the notebook, and then they store the executed notebook into some storage like S3 or MLflow, and then you can review those results later.
Great. Anyone else? Okay. Well, thank you so much, Eduardo, for coming back to us and showing your work. As a reminder, everyone, this is a monthly virtual meetup, and we generally meet the last Thursday. Yeah, last Thursday of the month. So keep an eye out on our meetup page for future meetups.
All right.
Good evening.
Thanks a lot. Bye.